here at my title page, I have included two images, one here on the left, which are stained astrocytes. They are stained for a marker which we call GFAP, glial fibrillary acidic protein, and this is a very characteristic marker for these cells. And here on the left we have neurons, which are stained for MAP2, again a very characteristic marker for mature neurons. And I have deliberately only given 1/3 of this panel to the neurons and 2/3 to the astrocytes to make a point, which I will build on throughout this presentation. So if we go a bit back to the end of 19th, early 20th century, when Ramon y Cajal was staining neurons, and throughout the 20th century we came up with these 5 postulates which comprise the neuron doctrine. So basically a neuron is an anatomical unit, it is also a metabolic unit. The information is moving only one way from the dendrites to the axon. The neuron is a developmental unit. And finally, around the 1940s, McCulloch and Pitts introduced this notion here that the neuron is a basic information processing unit. And eventually this became, instead of having the article "a" here, it became the basic information processing unit. So everything is about the neuron. And to show you how little we thought of all the rest of the cells in the brain, we collectively found the word glia to describe them, which is the Greek word for glue. So we tended to think that these cells are nothing but scaffold where neurons just stick to and receive nutrients from. So if we were to unpack a bit this word, we would see that we have oligodendrocytes. These are the glia that myelinate the axons, which is quite an important task. The astrocytes, which I will be talking about today, and also the microglia, which have a more of a housekeeping role, cleaning up the environment. So let's talk a bit about astrocytes. First of all, we had, for quite a while in the past few decades, we had this estimate that they outnumber the neurons in a 10-to-1 ratio. And everybody was going crazy saying, oh, we're only using 10% of our brains because we don't know what the glia are doing. Well, it turns out that actually a more accurate estimate is a 1-to-1 ratio. And this is with regards to an entire brain. If you take only the cerebral cortex, then there's a 4-to-1 ratio, but then the cerebellum is very rich in neurons, so it tends to bring back the ratio back to 1-to-1. And this is a very good study by the lab of Susana in Brazil, where she fractionated a number of